Alright guys, let's start the session. The first question is on your screen. A metal sphere is hung by a string fixed to a wall. The force acting on the sphere is shown in this figure. Which of the following statement is incorrect? Yes, Jen, right answer. Right, if anyone has joined right now, this is the first question on the screen. You have 2 minutes to solve this question. Anyone with the answer? Guys, shall we proceed with the solution?
तो आप कौन से भेजेंगे?
I'm sorry.
I sent you the answer.
No, Arnav, that's the wrong answer. Alright, guys, let's proceed with the solution. No, that's also the wrong answer. We have to see which statement is incorrect. Alright, r vector plus t vector plus w vector equals to 0. No, now that's the wrong answer. So, as this sphere is in equilibrium, it is not moving anywhere. So, all the forces are balancing each other. So, that is why A is a correct equation. So, this will be eliminated. Now, if we split the vectors, this becomes t cos theta and this becomes t sine theta. All right. So we have t vector which is equal to t cos theta and plus t sine theta. Is that right? So if you square it, t square, so we have t cos theta equals to w and t sine theta equals to r. So if you substitute these value and square, you will get B as a correct equation. So that will also be removed. All right. And then C is clearly the wrong equation because these magnitudes, they are equal or not, we cannot say. So this will be the right answer and R equals to W tan theta, which is, yes, if you divide both of these equations, then you will get cot theta equals to W by R, and from here you will get R equals to W tan theta. So D is also a right equation, so this option will be eliminated. Alright, clear to everyone? सबको आ गया समझ में?
Yes, sir.
Alright, next question. In the arrangement shown in this figure, if the surface is smooth, the acceleration of the block M2 will be. Guys, do you want some hints?
No, sir, just 1 minute.
All right, take your time. Yes, Jen, right answer. All right, guys, I'll give you a hint. See, if this string, in this string, if a displacement of x occurs, then this x will get distributed in this and this string by x by 2 and x by 2. Is that right? So when this string moves by x, so this string will move by x by 2. Alright, so the displacement or the velocity or the acceleration, they will be related to each other in this way. So suppose if this moves by acceleration a, so this will move down by acceleration a by 2. Alright, so if you are using this method. Is my screen visible? Hello, am I audible to everyone?
Yes, sir.
All right. Guys, shall we proceed with the solution?
Yes, sir.
All right. We wanted to find the acceleration of the block M2. So for M2, let's suppose the acceleration is A. So we'll take this as A. So for M1, it will become 2A. All right. So let's take tensions. So this, if there is T in this string, and so this T will be over here and here, and T and T. So this will become in this string there will be 2T. All right, so let's make FBDs for both of the masses. For M1, it will be nothing but T equals to M1 into 2A, and for M2, it will be this and M2G downwards. So this will become M2G minus 2T equals to M2A. So if we substitute this T from first equation into second, so we'll get M2G minus 2 into M2A. Taking this as M2A, So this will be m2g upon 4m1 plus m2. All right, that is the option A. Is this clear to everyone? Have a look at the solution and let me know if there is any problem. Anyone having any doubts? Or shall we proceed?
Yes, sir.
All right. Next question. In the system shown in the figure, mass of B is 4 kg and mass of A is 2 kgs. The pulleys are massless and friction is absent everywhere. The acceleration of block A is. Now here as well start with taking tensions, that is this is T, this is T. So here it becomes 2T and here is 2T. And similarly there will be the same relation in acceleration as well. Anyone with the answer? Yes, Jen, right answer. Shall we proceed with the solution? All right, let's proceed with the solution, guys. Okay, so we have found out the tensions in the strings, and regarding accelerations, we want to find acceleration of block A. So suppose this block A moves up by some distance x, so this outer thread will move by x by 2. So if this is moving by acceleration A, so this B will move down by A by 2. Alright, so now let's try to make FBDs of both the masses. For this mass A, which is at an incline, it is having a tension T, alright, and mg force downwards. So this is at an angle of 30 degrees. So we'll have to take components for mg. Alright, this is 30 degrees, so this becomes mg cos 30 and this becomes mg sin 30. Alright, so we have the equation for it as t minus mg sin 30 equals to ma. Alright, and Let's make an FBD for B. It has 2T and below it is having mg. Alright, we also have the values of masses. We substitute it in the next step. So we have mg minus 2T equals to m into what is a by 2. Alright, so substituting the values of masses, we have T minus this mass of A is 2, so this becomes 20 into sine 30 becomes 10 equals to A. And over here we have mass as 4, so this becomes 40 minus 2T equals to 4A by 2, that is 2A. So from here I have T equals to 2A plus 10, and which I substitute in this equation for mass B. I'll get 40 minus 4A minus 20 equals to 2A. That is 20 equals to 6A. That gives me A equals to 10 by 3. So A is my right answer. Everyone got it? किसी को डाउट है इसमें? Anyone? No one? All right. Let's proceed then. Three blocks are given with the same weight and they are hanging with a structure of springs. Then what is the tension in the spring connected between blocks B and C? That means this tension. Suppose you call this T1 and suppose you call these as T2. Because these are connected to different blocks, so we cannot say if they are related to each other. No, Jane, wrong answer. Obviously, there will be some tension. Otherwise, how is this C block going to be lifted?
So it's not being lifted, na? It's gonna go down towards the side of B and C. So
Even if it is going down, it is going to pull, right? C will be, it will appear as if it is pulling down the complete system.
yes,
Are you
sir.
getting my point?
Yes, sir, I am.
Tension in a string means that it is going to be taut. That means it is going to be not slacky. All right, guys, let's proceed with the solution. Let's suppose take the mass A for making its FBD. Uh, no, let's first see how the accelerations are going to be related. So this one is quite easy. If A is going upwards with acceleration A, then all of this will be coming down with acceleration A. All right. So I can consider this as a complete system for some while. All right. This system, because it is moving together. So if I take this as one system, then I can eliminate T1 from that relation. So I can get two equations for these two different blocks. That is for mass A, I will get T2 minus mg, m is 2. So T2 minus 20 equals to 2A. All right, and for this complete block, I have what is the total mass? This is 4. So 40 minus T2 equals to 4A. All right. So from here, I can let's add up both of these equations. So that will eliminate T2 directly. That will give me 40 minus 20, that is 20 equals to 6A. So A equals to 10 by 3. So if I take this mass C separately now, I'll have mg, that is 20 minus T1 equals to mass, that is 2, into acceleration A, I have 10 by 3. So 20 minus T1 equals to 20 by 3. So T1 comes out as 20 minus 20 by 3, which is 40 by 3. 60 by 3 minus 20 by 3 is 40 by 3. That is
13.3.
13.3.
So I thought there will be, I think T2 also applying on the last equation you've used. I thought कि T2 भी उसमें कहीं पे आएगा. That's why I think I got
नहीं
it.
नहीं 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 T2 यहाँ खत्म हो गया, ये स्ट्रिंग खत्म हो गई. This is a different string, this is a different string.
Okay.
All right, so that is why we cannot compare both of them. They don't have any significance on each other. All right, clear everyone? Let's take one more question for today. Two spheres A and B are placed between two vertical walls as shown in the figure. Friction is absent everywhere. the ratio of Na to Nb is. Maybe we should take a question of friction. Yes, let's take this question. The block B has a mass of this. The coefficient of friction between block B and the surface is this. I hope you have done friction as well.
Yes, so we have.
All right, then try this question. All right, actually, this is a tricky question. The answer to this question is zero. There will be no movement at all because the friction is going to stop the system completely from moving. Now, how do we come to that conclusion? Let's see that. So for that, we must first see how the acceleration and tensions are related. So if B moves with acceleration A, so this pulley will go down with acceleration 2A, and so this mass A will move down by acceleration 4A. All right, now if this is tension T,
They're opposite.
so
No, I think like the one which is down will move by a slower speed than the one which is up.
oh yeah, I'm sorry. This pulley will move down with A by 2, and this mass A will move down by A by 4. Now, if this is tension T, so over here will be 2T, and over the mass A will be 4T. So now here is acting a friction F. So this gives us a relation T minus F equals 2. Mass of B is 10, so 10 into A. And for mass A, we have, what is its mass? It is 16 into G, that is 10, minus 4T equals to 16 into A by 4. Now this is 160 minus 4T equals to
So
4A.
by 40, I didn't understand. Like I took it as 3T क्योंकि मुझे लगा कि एक साइड का 2T काउंट होगा और एक साइड का T काउंट होगा. 4T कैसे
नहीं,
हुआ?
ये स्ट्रिंग तो सेम है ना.
यस सर, तो इसका 2T हो गया और जो एक स्ट्रिंग ऊपर है उसका 1T शायद.
ये वाली,
यस सर.
यहाँ पे टी टी रहेगा.
यस.
तो टी टी है तो इसके नीचे वाले में 2T हो जाएगा.
यस सर.
ये 2T है तो ये स्ट्रिंग जा रही है ऊपर, तो इसमें भी 2T रहेगा.
यस सर.
तो 2T और 2T का 4T हो
अच्छा
जाएगा.
ओके, इन दोनों को ऐड कर रहे हैं. मैंने बस एक साइड का
हाँ
ले लिया कि एड टू 1 2T एंड 1T. ओके. ओके सर, फिर तो हाँ आना ही था बिकॉज देन इट वुड बी टू मच एंड जब हम माइनस करेंगे दोनों इक्वेशंस को देन आंसर विल कम इन माइनस.
हाँ, आंसर माइनस में आ जाएगा, तो उससे भी निकाल सकते हैं कि जीरो रहेगा. एंड अगर एक्सेलरेशन को जीरो रख के भी देखते हैं तो यहाँ से जो टेंशन की वैल्यू आएगी वो फ्रिक्शन से कम आएगी. ऑलराइट, लाइक यहाँ से अगर तुम देखो टेंशन कितना आएगा, अगर ए जीरो करो तो टेंशन यहाँ से 40 न्यूटन्स आ जाएगा. ऑलराइट, मतलब टी 40 न्यूटन्स तक मैक्सिमम जा सकता है. एंड अगर ए जीरो हुआ तो, और फ्रिक्शन की मैक्सिमम वैल्यू क्या हो जाएगी, म्यू एम जी, दैट इज 0.5 इंटू कितना 100, दैट इज 50 न्यूटन्स. तो टेंशन ज्यादा हो ही नहीं पाएगा, तो इसलिए फ्रिक्शन उसको कंप्लीटली कंपनसेट कर लेगा. ऑलराइट गाइस, दैट्स ऑल फॉर टुडे. किसी भी क्वेश्चन में डाउट हो तो पूछ लेना. आई थिंक सबको आ गया है समझ में. ऑलराइट गाइस, थैंक यू फॉर ज्वाइनिंग. बाय बाय.